Welcome, everyone, to this explainer. Okay, let's just dive right into our clinical audit of the massive paradigm shift that just completely redefined the AI frontier. Between May 24th and May 30th of 2026, we witnessed this concentrated burst of architectural and infrastructural realignments that, frankly, fundamentally altered the trajectory of the entire enterprise technology sector. The data we're about to review unequivocally demonstrates that the era of brute force, dense parameter scaling, it's over. The frontier is now strictly defined by recursive self-improving workflows, massive physical infrastructure entrenchment, and hyper-sparse orchestration.
Here's our blueprint for today. We're going to sequentially break down the strategic maneuvers of the Big Four developers and Nvidia to deliver the macroeconomic extrapolations you need for immediate enterprise planning.
And just look at this timeline. This captures a brilliantly compressed time frame. Literally a single week in late May 2026, where the industry permanently transcended passive text generation in favor of actual agentic workflows. Virtually every major player executed a structural pivot at exactly the same time. So let's analyze these moves sequentially, starting right at the algorithmic layer.
Section 1. Meta, Sparsity, and Wearable Distribution.
Meta's highly synchronized strategy perfectly demonstrates this shift toward hyper-efficiency. You'll notice a stark architectural divergence between their two newly launched Llama 4 models. The Maverick architecture pushes extreme sparsity, utilizing an unprecedented 128 experts to route operations, but actually only activating 17 billion parameters per token out of a massive 400 billion parameter pool. This yields a totally unmatched performance-to-cost ratio. Now, on the flip side, the Scout model limits its experts to just 16. Why? To entirely prioritize a massive 10 million token context window for deep document synthesis and extensive codebase refactoring. Like I said, the monolithic parameter race is dead. The future is dynamic routing.
But listen, Meta isn't just winning in the cloud. They're pushing the Pareto frontier to the absolute edge. They've formulated this novel on-device mixture of expert scaling law with mobile MOE, deploying sub-billion active parameter models directly onto commodity smartphones. These require up to 4 times fewer inference FLOps than dense alternatives, while totally matching their performance. Simultaneously, they deployed AutoFormBot. This is a multi-agent system that acts like a collaborative software engineering team to translate complex graduate-level math into machine-verified code. It's already generated a monumental library of 45,000 verified declarations in the Lean 4 language.
To power all of this, Meta's 2026 capital expenditures have surged to a staggering $145 billion. But here's the kicker. This capital isn't just for cloud data centers. It's being deployed largely to circumvent mobile operating system duopolies by pivoting hard to ambient wearable hardware. By pushing the limitless AI pendant and their new smart glasses, Meta is attempting to establish an ambient, always-on physical interface. Whoever controls that continuous audio-visual contextual data commands the entire data flow. Section 2. OpenAI, Autonomous Loops and Biodefense.
Moving to our second blueprint, OpenAI's trajectory reveals a highly calculated shift away from consumer chatbots and toward deeply embedded, self-correcting enterprise and defense moats. The crucial point here is how they achieve measurable, recursive self-improvement in live production. Take the AI tax agent they built with Thrive Holdings. We see a clear autonomous loop here. When an accountant corrects an error, the system captures a production trace. It then clusters these failures, bounds them in a read-only context, and allows the Codex model to safely rewrite its own operational logic to fix the root cause before submitting a pull request. This specific autonomous loop drove field accuracy from 25% to 97% in just 6 weeks. Software isn't static anymore. It's practically a quasi-biological system using human corrections to mutate and improve its own code.
And alongside that autonomous software, OpenAI is building a massive geopolitical moat through what they're calling defensive acceleration. They have granted direct, zero-cost access to a highly specialized frontier model called GPT-Rosalind, engineered specifically for life sciences, straight to the U.S. defense apparatus. Institutions like the Lawrence Livermore National Lab are pairing it with supercomputers to design medical countermeasures. OpenAI is actively transitioning from a mere software vendor to a critical component of national biosecurity architecture.
Section 3. Google DeepMind, Accelerated AGI and Discovery.
Let's see how all this builds into an accelerated horizon for AGI through automated algorithmic discovery. Google has operationalized AlphaEvolve. This is an evolutionary coding agent that pairs creative problem-solving with automated mathematical evaluators. It has fundamentally altered computer science math by designing completely new, faster algorithms for matrix multiplication.
Even more practically, it actively recovers Google's worldwide compute bandwidth by autonomously optimizing data center orchestration without human intervention. It's effectively creating free global computational bandwidth just by refining heuristics. We're talking about algorithms designing algorithms.
Driven by these breakthroughs across biology and computer science, CEO Demis Hassabis has starkly recalibrated the industry AGI timeline. He now cites 2029 as a very real possibility for reaching artificial general intelligence, warning that humanity is undergoing a species-level transition and literally has very little margin for error. The benchmark is no longer just mimicking text, right? It's autonomously deducing a century of scientific advancement from scratch.
Section 4. Nvidia. Orchestrating the agentic era. As applications transition to these multi-step agentic workflows we just discussed, Nvidia is fundamentally restructuring the hardware paradigm to match it. At a macro level, legacy x86 CPUs create severe bottlenecks. They waste massive amounts of energy just trying to feed data to powerful GPUs. Nvidia realized that agentic AI is actually heavily CPU-bound. Workloads like constant code compilation, runtime execution, and database querying require fast cores and immense memory latency control. Enter Nvidia's new Vera CPU. This is custom-engineered for the exact orchestration required to manage millions of autonomous agents simultaneously in production.
The specs on the Vera CPU are incredibly clinical and targeted. You've got 88 custom Olympus cores on a monolithic die, paired with a staggering 1.2 terabytes per second memory bandwidth. In independent benchmarking, Vera delivered a 1.5x performance advantage over leading 128-core x86 alternatives. It famously compiles a Linux kernel in exactly 20 seconds. This is a mandatory architectural leap that will directly power Nvidia's vision of massive AI factories modeled via their Omniverse digital twins.
Section 5. Anthropic. Hyperscale enterprise capitalization. Next up in our sequential ecosystem audit is Anthropic. They've rapidly evolved into a highly capitalized infrastructural utility layer for global commerce. Backed by the global financial elite and sovereign wealth funds, Anthropic just closed a monumental $65 billion Series H funding round. This event pushed them to an astronomical $965 billion post-money valuation.
But to be clear, this near-trillion-dollar valuation isn't purely speculative. It is anchored by a staggering $47 billion annualized run rate revenue. And more importantly, this capital secures multi-gigawatt physical capacity lock-ins across Amazon and Google, as well as prioritized access to alternative hardware like SpaceX's Colossus clusters. Anthropic is securely insulating itself from global memory and power crunches to guarantee physical execution for its enterprise clients. However, the economic incentives driving this unprecedented enterprise efficiency have triggered severe socio-cultural friction. This was really brought to light at the end of May when Pope Leo XIV released the Magnificat Humanitas encyclical. This document explicitly condemned the exact white-collar automation that these tech giants are scaling so rapidly. We are seeing a very stark contrast between immense ethical concerns over macroeconomic labor displacement on one side and the reality of Anthropic's deep integrations into massive 200,000-person workforces at firms like KPMG and PwC on the other.
Section 6. Strategic Macroeconomic Extrapolations.
Okay, let's synthesize these isolated corporate strategies into the definitive macroeconomic directives you need for your enterprise architecture right now. The clinical takeaways from this infrastructure audit are undeniable. First, the monolithic parameter race is dead. Operators must transition entirely to hyper-sparse mixture of expert adaptation. Second, you have to prepare your data center infrastructure for tighter integrations of sequential orchestration CPUs like Vera over legacy x86 models. Third, your software stack can no longer be static. It must rely on self-amending code loops that utilize human corrections for autonomous refinement. And finally, you must recognize that physical hardware distribution, ambient edge wearables, is the absolute ultimate battleground for continuous data flow. So to wrap up our explainer today, I want to leave you with this final structural question. If frontier AI is executing a merciless vertical integration, controlling everything from the orchestration silicon to the self-correcting algorithmic logic, right down to the physical wearables tracking our daily context, how long until enterprises relying on static software APIs face irreversible structural obsolescence? It's something you need to consider as you immediately audit your own organization's technological stack against this newly established frontier. Thank you so much for joining me, and I'll see you in the next analysis.